Hello, welcome everyone. We are starting now the fifth virtual session of the Xylella-fastidiosa workshop from diagnosis to management. It's a pleasure to me being the moderator of this session, and thanks to the organizers to give me this opportunity. As general information for all the attendees, this workshop has been organized in partnership between the Escola Superior de Agricultura Luis de Queiroz from the University of Sao Paulo through the Laboratory of Insect Vectors of Plant Pathogens, and also the Citriculture Center, Instituto Agronómico, through the Laboratory of Biotechnology. And the workshop is supported by the CITED and Iberxifas Red Iberoamericana para la Vigilancia de Xylella fastidiosa, the Department of Entomology and Acarology, from the University of Sao Paulo, and the graduate program in entomology from the University of Sao Paulo. And this workshop is designed for researchers, professionals, growers, and students. And the two main goals of the workshop are to provide an updated overview on the plant pathogenic bacterium Xylella fastidiosa, its importance, classification, host plant iterations, transmission, detection, and monitoring, as well as on management and certification strategies, and also to provide a training on research techniques related to the pathogen and the vectors. The workshop programs includes 5 virtual sessions. This is the last one on Thursday from 11 a.m. to 1 p.m. Sao Paulo time, broadcasted through YouTube, and practical sessions during September from 5 to 7 September at the University of Sao Paulo and at the Citriculture Center of Sao Paulo State in Brazil. And if you want more detailed information of the program, you can check the workshop website that is posted in the chat. And in this website, you can also, this is important, you can also find the YouTube links to the recordings of the previous workshop sessions and in the future of this 5th session. Today, we will have 3 speakers with 3 talks from about 50 minutes. After all the 3 talks, we will have a debate because there will be no questions during the talks, only during the debate. However, all the audience can post their questions in the chat during the talks and the debate. And there will be a list of attendance. For that, there will be a Google form posted in the chat, and a certificate will be awarded for attendees that has been participating in at least 3 virtual sessions. Okay, so it's the time to start the 5th session, and I want to present the first speaker. The topic of the talk of the first speaker is update status of Xylella fastidiosa in Central America, and the first speaker is Carlos Chacon. Dr. Chacon has a Bachelor of Science and Master in Science in Microbiology from the University of Costa Rica, a PhD in Microbiology, University of Costa Rica, and currently he is Associate Professor in the University of Costa Rica, the College of Microbiology, Department of Bacteriology. His research focuses on bacteriology and microbial pathogenesis, with several publications related to Xylella fastidiosa in collaboration with different research centers. And after this quick presentation, Carlos, you can begin the speech.
Thank you, Francisco, for your kind words. Hello, everybody. Good morning and good afternoon for the people that are not in the American time. I want to thank the organizers for giving me this space to talk about this topic that is about the Central American region. This Costa Rica and Xylella fastidiosa from Central America has been a recurring topic in the other sessions, and this is a good opportunity so you can have a view of how we see Xylella, the potential of Xylella fastidiosa in Central America, so you can have this insight and compare it to other regions that were already characterized, and there were other sessions about them. So the first thing is I want to show you what the region that we are going to talk about. For this topic, Mexico will be, although Mexico is part of North America, in regards of Xylella, we will include it as part of this region. As you can see in the topic, there is a lot of lacking basic information about Xylella in Central America. This is a geographical zone that is in tropical weather. We have a lot of rain, and we have only two seasons, rainy and dry season. And all of these countries share a lot of biodiversity factors and geographical factors. And the islands here, the Caribbeans, are also have their own ecosystems and particularities that have to be taken in account in this kind of topics to understand how Xylella is present in this area. So if you go to an official global report of Xylella, you will see what is known really, that Xylella really is an American pathogen until recent years when the outbreaks in Europe took place. But if we pinpoint to the Central American region, you can only see that in the official reports, we have only 3 countries that have reported or have official reports of Xylella. These include Mexico, Costa Rica, and Puerto Rico. If looking for more evidence or information, public evidence, you can find some data or some work done in Guatemala on coffee that the results show that there is Xylella present. Also in Honduras, this was done also with European interception on coffee plants that were in coffee trade to Europe. In these interventions, they were able to isolate and characterize some Xylella coffee isolates from Honduras. And Nicaragua, there are also some studies regarding dissertations from universities related to citrus and vectors. So if we take in account Guatemala, Honduras, and Nicaragua, we could close the gap from Costa Rica to Mexico. And this is important because this is like an insight and a potential to explore how is the Xylella, how is Xylella is distributed, and what is the real picture of its condition throughout Central America. For now, most of the information we have is on work done on Mexico and work done in Costa Rica. So I'm going to focus on these types of works that are published, so you can have an idea of what is the status in Central America. First, I'm going to start with Mexico. Mexico is a very big country, and it has a particular condition, that is that they grow grapes, they have vineyards, and they have to deal with Pierce disease control. So when the vineyards that are located near the border with the United States, well, this kind of isolates of Xylella would tend to be similar to the ones that have been reported in the south of the United States and California. And because of climatological weather and conditions that may look or seem more likely to be from North America than south, the part of more like tropical region of Mexico. So they have to deal with Pierce disease and to control Pierce disease in their economic activity. In this recent study by Aguilar Granados, they have isolated some Xylella fastidiosa strains from different places of these vineyards. And as you can see, the red points are the isolated strains, and they did some genetic profiling of these strains. What they see is that they tend to be from the Xylella-fastidiosa group. That is what is expected. When we look closely to the diversity, you can see that the strains that were isolated near the border with the United States, those strains are similar to the ones present in California. But interestingly, the ones that were characterized from the central part of the country are more similar to the strains that have been characterized related to Costa Rica. So maybe from the central part of Mexico to the south, there might be more potential of exploring diversity of Xylella fastidiosa strains that are present and that we foresee as endemic in the Central American region regarding Xylella fastidiosa. In Mexico, there have been also other studies like this one where they look and screen for potential host plants, and they have an inventory of all these potential plants, and they take all this information with to do some kind of like risk map or potential or probability of Xylella appearing in some of these landscapes. So this is some work that has been done in Mexico related to Xylella fastidiosa. In the case of Central America, I'm gonna jump to Costa Rica. The first report was done here in Costa Rica in the 1970s. This is the report in 1979. And this is a report from people, from grape growers that came to Costa Rica. They wanted to do vineyards and have some wine activity in a dry part of Costa Rica. And what these plants got Pierce disease. So they sent them back to California and did all the analysis. And what they got back is that these pictures that are from this paper, you can see that these are isolates and electronic microscopy that relates to Xylella fastidiosa and antibody detection. So this is the first report. In this time, the bacteria was not called Xylella fastidiosa, but evidently is Xylella. From this point on, most of the work that has been done in Costa Rica is related to coffee, because in the 1980s, 1990s, coffee growers started reporting something they called crespera. Crespera, it means leaf curling. So it's a mild disease. It doesn't go up to coffee leaf scorch as reported in Brazil, but what in the 2000s there was the relation between the presence or the disease called crespera and Xylella fastidiosa. To that point, then this was studied, and Xylella is present in all the coffee regions in the country that usually are in highlands. And they seem to be, because you don't see, more like colonized, asymptomatic, or mild symptoms in coffee. It's not an issue in coffee production, because there are other diseases that are really impact coffee production, and not Xylella disease crespera. So there are no real estimates of this in coffee production, the real impact of this on coffee production. So the research started with coffee, but there has been detection of Xylella in grapes, in citrus, in avocado, in nerium, oleander, in vinca, in guava, and some other strains that with different methods have been reported as Xylella positive. We don't see many drastic symptoms, as I mentioned, but in nerium, oleander, and and vincas, we really see diseased plants. These are the two hosts that we have seen that show more symptoms in Costa Rica. And we have screened some economic and native plants, and this is an ongoing work. This is just an example of this, but it's an ongoing work to try to look for reservoirs and potential susceptible hosts. Here is just for an example. As you can see, most of our positive plants are related to the central part of the country where this is highlands. And we have surveyed some parts that are more related to lowlands using sentinel plants or susceptible hosts. But this work we have to keep on doing to have more precision, because we need to know if the lowlands are a limit to the presence of Xylella in some geographic parts of the country. Through the years, we have been able to isolate different Xylella strains that were circulating, usually related to coffee. And this has been important because this has been an input to study Xylella and in the global context, to know or to feature how are the Xylella fastidiosa strains, fastidiosa from Costa Rica or from Central America in relation to other parts of the world. In this paper in 2020, with using whole genome sequencing, you can see that we have two subspecies of Xylella present in Costa Rica. One that is a fastidiosa, subspecies fastidiosa, that shows a lot of diversity in comparison to the North American California strains. So it's a unique population with a broad genetic diversity. And then is the pauca subspecies that that it seemed to be introduced from South America. This is an example or a phylogenetic time measure that was done some years ago by other researchers, where they show that that the possibility that this pauca strain really is introduced to Costa Rica or to Central America, and that eventually, with some recombination, this has been the strain that eventually was introduced into Europe with all the Italian outbreak that you've heard in previous sessions. So we have done genetic diversity using different types of techniques. One that was used was MLST analysis, but I'm just, with this example, show you a limitation of MLST when you have a lot of genetic diversity. As you can see, here we have from the whole genome study, two strains that are phylogenetically distant, but they have the same ST. So this is just an example that this MLST may be limiting when you have a lot of genetic diversity, and that you need to use other techniques that stay or show this diversity without confusion. So another technique that we have used is microsatellite analysis, and this one usually gives us a better result in diversity. As you can see here, all of these Xylella fastidiosa strains show a lot of diversity. If you see the difference in the size of the black bars, and when you go to the Xylella fastidiosa pauca of circulating strains, you can see that it's more at least genetic diversity. So this is a good mirror of what have been seen in whole genome analysis. So one of our goals is to keep on looking for Xylella fastidiosa and to extend the limitations or the geographical presence of Xylella in different parts of the country, especially trying to focus more on lowlands that there is where there more lack of information related to Xylella. This is a nice example of what we see sometimes in regarding Xylella. Here is in Xylella in urban conditions where there are still some coffee plantations embedded in the city. Here's the university, and this is a 4 kilometers for 4 kilometers map. As you can see in this square, there is a lot of potential diversity of Xylella fastidiosa, even among the same coffee plantations. So this gives us a lot of work because there are still a lot of questions to answer. How similar are these strains phenotypically? That is the importance, because this is related to disease. What are the genetic differences among the strains? How close are we of uncovering the total diversity present in the Central America? What is the pathogenic potential of these strains? What about vectors? Because we have worked a lot of the strains, the host, but we have left aside and need to work on vectors. So these are some of work we have done on phenotypic characterization. As you can see, there are differences among the strains with its potential to produce biofilm. Interestingly, the strains that showed symptomatic plants are the ones that show less ability to produce biofilms. We have done some mechanical inoculation of strains in plants that may be interesting for other latitudes, such as grapes and oleander. And what we see is that these hosts are not a preferred one for the strains that were isolated mostly from coffee. So this is not the preferred host, and this is important thinking of other latitudes or the potential risk of these strains in other latitudes. Regarding the vectors, there has been a lot of work in Costa Rica, but doing inventory of species, not necessarily related to Xylella fastidiosa, but there are some work of inventory done in coffee plantations. Also some in population dynamics of vectors in these coffee plantations conditions. But in recent years and within our group, we are doing work on vectors, and we are going back to the coffee plantations and trying to establish absolute and relative abundance of psychedelics in coffee plantations. We have done some confirmation of transmission, because this has not been done in Costa Rica, or as I know in the Central American part, and we have done it using artificial transmission assays. But also we have been doing these assays in coffee transmission assays, where we now have some data regarding Xylella fastidiosa transmission. So now we can eventually say that some of these potential vectors are really vectors of Xylella fastidiosa in our conditions. And if you can see, possible all of these psychedelics are similar or are related to the ones that have been presented in previous sessions related to South America. So in our conditions, this is what happens. We have a small country with a lot of biodiversity, a lot of these cultures, monocultural plantations, are embedded in areas where I believe that there are still a healthy ecosystems regarding the monocultural activity. So really we have a lot of diversity in vectors, a lot of possible host plants, and diversity in genetic strains. So it would be still like a natural environment where there is an ecosystem equilibrium. And this is a healthy ecosystem, although there is monocultural planting or activities. So this is maybe the explanation why we don't see these epidemic outbreaks, and we have more like a colonized equilibrium of the bacteria within its environmental conditions. The problem is when these bacteria the problem is if this is like a melting pot. These bacteria, these Xylella strains are recombining, and one of these recombinations can follow or lead to a pathogenic strain. The best example you should know is the presence of one of these strains, the ST53 strain, that was related or is related to the one present in Italy, where there is a very efficient vector and a very susceptible host. So in conditions with a healthy ecosystems or diversity within the ecosystem, these strains probably are harmless, but these strains in other conditions have been drastic. So this leads to our why Costa Rica is related to the European outbreak, and this is mostly Central America also, is the plant trade, because at the end the relation is that these Codiro strains isolated from the olive trees are phylogenetically related to some pauca strains that were isolated and characterized from oleander from Costa Rica. So the working hypothesis is really that ornamental plants within the plant trade business was a point of introduction. And this is not only for Central America, because this is the Italian example, but for other European countries like Spain, there are usually strains that were related to North America. What is the problem of Xylella in our countries? It's not really that it's affecting our agricultural crops, but these measures can affect some of our activities, such as all activities related to plant trade and exportation. So when the outbreak in Italy came out, Xylella fastidiosa impacted Costa Rica, but in a socio-economical way, because when the measures that were taken closed a lot of the possibility of exportation of plants to the European Union. So this led to a lot of this business closing, that led to a lot of people losing their only source of funding in places of the country where the economical activity is not very high. There were some efforts to enlist this plant, Phoenix robillini, that was one of the most exported and most prominent activity. And but now, this was around 2015, 2016. Now people have understand that if they want to export and do business with plant trade, they have to confine and be in line with all the measures that are necessary to do this type of activity. And there is a recent effort between the plant protection authorities and a private company that pursued this Xylella fastidiosa free status, so they can do business with other countries in Europe. So why is important to do surveillance in endemic surroundings? Well, because usually we have a healthy ecosystem that is driving or maintaining the equilibrium of the Xylella pathosystems. But eventually, the high prevalence of Xylella fastidiosa in plants, the broad diversity of Xylella circulating strains, the recombination activity of these strains may lead to pathogenic strains that may favor and displace other genetic strains, the broad diversity of vectors, and environmental and agricultural practices that may favor conditions for the development of outbreaks. So we must surveil that the equilibrium ecosystem is healthy, and any change in these conditions that you have to be aware of, because it may be the driver, the spillover to have an outbreak even in Costa Rica or in Central America, or eventually, as has happened in recent years, that these strains reach other ecosystems that have efficient vectors and susceptible hosts. Just for concluding, so as you can see, we have more questions and knowledge gaps than answers. That is good and bad, but we need to keep on doing efforts, not only in Costa Rica, in Mexico, but throughout all the Central American and Caribbean region, because we have an incomplete puzzle. And if we have an incomplete puzzle, there may be perceptions and differences of what we are seeing, and this may be a misleading to the people that have to take decisions regarding Xylella in our countries. And with that, I just want to thank people that have worked and are working on Xylella fastidiosa, our group that is from 2 research centers in Costa Rica, and also some valuable collaborations from Phyllis Weintraub from Israel and Rodrigo from Universidad University of Berkeley, sorry. And the last Xylella projects have been funded by Ponte Project and X Factors that we have been part of for the past years. And I want to thank you for your attention, and that would be my presentation.
Thank you, Carlos. It has been a very complete presentation on the situation of Xylella fastidiosa in Central America, mainly in Mexico and Costa Rica. Thanks. And now it's time for the second speaker, the second talk. The topic of this talk is regulatory measures in Europe, and the speaker is Amparo Ferrer Matoses. Dr. Ferrer is an agricultural technical engineer from the Polytechnic University of Valenciana, and an agricultural engineer specialized in plant pathology from the University of Lleida. She has worked in the plant health service of the regional government for 18 years. In the latest 10 of them as a head of the phytosanitary inspection section in charge of quarantine organisms. And regarding Xylella fastidiosa, she has been in charge of the disease control management since 2017, when this pathogen was first detected in Spain, in the province of Alicante, by designing a statistical and risk-based service for the delimitation of the disease in the demarcated area and also out of it. She has collaborated with EFSA in various working groups related to different harmful organisms, as well as in the preparation of risk-based service related to Xylella fastidiosa. So, Amparo, when you want, you can start your presentation.
Okay, thank you. Thank you, Paco. Thank you, Francisco. Thank you for your work, for your kind words. As he said, I work in the plant health service in Valencia. Well, sorry, because it's the last one. I have to go to the beginning. Sorry. Okay, legislation is always very boring, so I hope you have your coffee here, okay? And I will try to do the presentation less boring as I can. The first thing that I want to explain you is just a little, because in 2019 we have the bigger change in the European phytosanitary legislation. We have passed from one main directive, the Directive 29/2000, to many regulations, more than 160. So the regulations are better than directives because they have the direct application. They do not need to be transposed. And in addition to these regulations, we also have the emergency decisions and the contingency plans that are mandatory for some pests. So at the end of this year of 2019, we have the big change, and with this change now, up to now, the current legislation for Xylella is based in 4 main regulations. 4 main, okay? We have other, but the main are these 4. 3 are general regulations, and 1 is specific for Xylella. The main regulation is the PHR. Here is the regulation 2031 of 2016 is the plant health regulation, and this is the basis for the rest of regulations. Okay, so for instance, we have this other one that is very important. These two is the official control regulations, and the main implementing regulations that we use for Xylella is the uniform conditions regulation that is stated here in 2072 regulation. This is to apply to develop the basis of the plant health regulation. Okay, and then we have the specific one for Xylella, and it's an implementing regulation from the Commission, and it's the number 1201. Sorry. Well, with this new legislation, we have a new pest classification in these four lines: the quarantine pest, the priority pest, the protected zone quarantine pest, and also we have another line with regulated non-quarantine pest. Okay. This classification is in the plant health regulation, but in the others we have, for instance, in the uniform conditions, it lists in the annex for the quarantine pest what is considered, or what is the name of the quarantine pest, the list of its quarantine pest. So in Annex 2 of this regulation, we have the list of the quarantine pests for the Union, divided into 2 parts. In Part A, the pests that are not known to occur, and in Part B, we have the ones that have been detected in the Union. And here in this part B, we have Xylella fastidiosa. We have more than 175 quarantine pests. So Commission decided to list 20 of these quarantine pests, 20 of these 175, and give a special name that is known now as priority pests. They are all quarantine pests, but they are selected because they are more dangerous, not only for plants, but also at a level of economic level and social level also. So in this list, at the end, we have Xylella fastidiosa. We just have 2 bacteria. One is for Candidatus liberibacter, of HLB, and then Xylella. Well, so with that, we have the classification of Xylella in the European Union is a quarantine pest because it's in the Part B of Annex 2, and also is a priority pest. And then with the specific, talking about the specific regulation, we have the regulation 1201, and it was published in 2020 in August, and it repealed the previous decision that was amended a lot of times. So finally, they published this regulation. And with this new regulation incorporates a lot of novelties compared to the previous legislation, not only for definitions, but also for measures to be taken. These are the main points that we have in the regulation, and the points that we are going to see. the first of all is the definition, because it's very important to understand and to apply this regulation to know the difference in with host plants, what is a host plant and what are specified plants. Okay, when we talk about host plants, are all the general species that are in Annex 2 of the, in Annex 1 of this regulation, and are all the plants or species that have been detected. Xylella has been detected worldwide. Okay, but the specified plants are the host plants, but they are related to a specific or subspecies. Okay, this is a list with 3 lists. This annex has 3 lists: one for pauca, one for fastidiosa, and another one for multiplex. So when we talk about surveys, we use always host plants, because we have to sample, or we have to do the surveillance with all the possible host plants. And when we talk about destructions or plants for planting, about nurseries, okay, we are talking about specified plants, because are all the plants related to the subspecies that they detected in an outbreak. Here we do have some examples of the general species that we have in Annex 1. It's very long. I have some little photos, but to see that, as you know, Xylella could affect to a lot of different species. So in this photo is for Annex 2, okay? And as you see, we have a list for Xylella fastidiosa. Another list, this is a short, this is just a photo. We have a lot of hosts, of course, for multiplex and also for pauca, for the 3 main strains or the 3 detected in the European Union. Well, the mandatory surveys, okay? As it is considered a priority pest, there is an obligation to carry annual surveys. For quarantine pests, we can do the surveys pluriannual because there are a lot of quarantine pests. But for priority, the 20 priority pests, we have to do surveillance every year, okay, inside the territory. These surveys have to be done with statically sound and risk-based surveys using the EFSA Ribes, it's a tool, the EFSA tool is Ribes Plus. All the surveys have to be done everywhere, outdoors, of course, in fields or in orchards, of course, inside nurseries, in garden centers, cell centers, natural areas, everywhere. Then the sample collection and the analysis must to be done with a system scheme that allows to detect with a confidence of 80% a minimum level of presence of infected plants of 1%. Okay, this is applicable on the next January. Up to now, we use the ISPM number 31, and our inspections or our surveys are based on the ones that are stated in the National Contingency Plan for Xylella. But in January, all the members have to use in the areas outside of the marketed area, okay, in the rest of the territory that is not at the marketed area, have to use these 80% and 1%. Of course, we have to prospect in the right time, and we have to take on count the pest vector also. And with this new regulation, only molecular analysis are allowed, okay, are permitted. Up to now, ELISA was also, but since this new regulation, just the molecular analysis, Harper, Oyan, Minsabas, Lamb, okay, all of these that are in Annex 4, but only molecular. And of course, there's an obligation to have each country must have a contingency plan with all the measures that in case of detection and before a detection, all the measures for the surveillance. This is a photo that I put here with all the points so that we have in our region, that we have taken samples. This is the map of only for 2020. The points are for 2020. If I put all the points that we had, all the map really is is full. So since 2017, our first detection was on June 2017, we have taken more than 31,000 samples outside the demarcated area. As you see, the demarcated area is here because this part is empty. We will see later. But for the rest of the territory, you have more than 31,000 samples. What is a demarcated area? Well, once you found or you detect Xylella, the regulation states that you have to work in demarcated areas. That is, the infected zone is a summatory of the infected zone and the buffer zone. An infected zone is a radius of at least 50 meters around the plant that has been detected as positive, and the buffer zone are 2.5 kilometers radius from the border of the infected area, the infected zone. Okay, this is for eradication measures, but if we are in a containment plan, the buffer zone is 5 kilometers. There are exceptions for establishing demarcated zone areas, of course, and also the option of the demarcate with 1 kilometers, but it's not the most current act. The normal is just have a demarcated area with 2.5 kilometers for eradication. If the subspecies of this detection is confirmed, if we know if it is Pauca, multiplex, or fastidiosa, then this demarcated area is demarcated for this subspecies. So we will destroy only the plants that are related to this subspecies. Okay, but in this annex 2, the list of plants is related only to the subspecies. It's not related with the sequence. With the ST of the bacteria. In our region, we have detected only one ST number 6 in multiplex, okay? Then the demarcated area may be left if, after carrying out all the surveys in 4 years, we don't detect the presence of the bacteria, so if this occurs, well, we can leave the area. And we have one similar case, not similar, but one case that was listed in Andalusia, and well, in Madrid they have one detection, and probably this year the demarcated area will be lifted. And there are also special conditions for the demarcated area of the 1 kilometer buffer zone, but this is not the normal. This is a map of our demarcated area. Carles, my colleague Carles, that talk later, will also explain you. But well, this is my country, Spain. This is my region, Valencia, and in the south part of the region, Alicante, in the province of Alicante. Here in the north part, very near of the province of Valencia, we have our demarcated area that is really very big because it's near 138,000 hectares. As I told you before, the only detection that we have now near 4,500 positives, and always detect the same Xylella fastidiosa multiplex and ST number 6. When we detect, regulation says that we have to do the eradication measures. When eradication is not possible, then we have the chance to change to containment. But the change to containment is very difficult and it's not so easy. So the first option always is eradication because it's a priority pest and of course a quarantine pest. In eradication measures, we have measures for removal, measures for vector, measures for destruction, for surveillance, and other relevant measures. With regard of the disposal of plants, well, all the plants shall be removed immediately. Immediately, it states. Well, it's not so easy to do it immediately, but well. And what do we have to remove? All the plants in which infection has been detected, of course. All the plants showing signs or with suspect of being infected. All the plants belonging to the same species detected as positive, okay, irrespective of their health status. We don't know if it is positive or not, but we remove all the plants of a species that have been positive in the same demarcated area, has been positive, perhaps in another period of time, okay? But we detected on March 1, for instance, Calicotome, and in September, Prunus. Well, in the part where we detect the Prunus, if there are Calicotomes, we also have to remove Calicotomes, okay? So, and there are all the specified plants must be removed. All the specified, all the list of plants related to subspecies multiplex. But we have an exception if we can test molecular test, of course, sampling and molecular test of these specified plants that never have been positive in our demarcated area. If we test them and we demonstrate that they are not positive, so we cannot remove them. We have here in my region, we have a direct application of that with Olea europaea, because it's a specified plant for Xylella fastidiosa multiplex, but up to now, in 5 years, we've never detected Xylella in Olea. So we do not remove the olive trees in our demarcated area, only the prunus and the other 21 different species, but not olives. The destruction must be in situ, in the plot, okay, or in a nearby location, but of course, if you have to go to another part, in a closed containers. So the better option is to destroy in situ in the plot. Now with this new regulation, we can limit the destruction to the branches and the foliage, and then this wood, you have to treat it, of course, and then the root system that stays in the soil, you have to treat it. You have to devitalize with an appropriate phytosanitary treatment to prevent new outbreaks. Also talks about the vector control measures. We have to treat the infected zone prior to the removal of the plants. We have to do a monitoring of the vector in all the demarcated area, not only in the infected zone, but also in the buffer zone. And the management of this vector must be in all its phases of the vector, from the eggs to the adults. So we can use chemical treatments, or biological or mechanical, but we have to manage the vector. And also it states the regulation that the country can't adopt measures to deal with complications or particularities that delay or avoid the destructions. This is because also in Apulia and in our region in Alicante, we had a lot of problems with people because they don't want to destroy all the plants. They want to destroy the infected one, but not the 50 meters around, because there are a lot of plots inside here. Our plots are very small, so probably all the plots will be destroyed, so they don't want, and they are very hard against us and our measures. But it's just what the regulation states, it's not our opinion. So but well, in Apulia have the same problem or similar, and finally the commission states that the country can take measures. Well, these are photos of how do we perform the treatments before or prior to the extractions. The treatments are done with deltametrin or with lambda-thialotrine. These are the ones that are permitted to our crops in this area. This is a machine for destroy. We have different kinds of machines because our demarcated area is very huge, and it has different parts with mountain or other parts that are very, very plain. So, well, you need different machinery. This the saw, or this is the threading machine, because we thread all the trunks and all the branches, and this is the root that is inside. So we have treated to devitalize it and to avoid the new outbreak. Well, about the vectors, we have to do the surveillance also in the demarcated area, and inside the demarcated area we do this control with entomological nets. We put also some chromotropic yellow sticky traps, but they are mainly in outside the demarcated area. Okay, but inside the demarcated area, we work with these nets to do the monitoring of the vector, to see the adults or the nymphs where in which phase, to give the recommendations to the farmers to treat when they are in the appropriate moment. Okay. Talking about the surveillance of the demarcated area, as I said before, it must be with space. Okay, so for that, and the regulation give us only this information. It says that it's with space, and we need, for infected areas, we need a 90% of certainty or confidence level that allows us to detect the presence of infected plants of 0.5%. This is for infected areas, okay? And for buffer zones, instead of this 0.5 is a 1%. In this part, in the buffer zones, the regulation divides the buffer zone in two parts. The first 400 meters that are highly risky. They are risky because of proximity to positive plants, and the vector is the main, of course, vector of the disease in that area. So it's easy for it to go from one plant to another, very near. And also we perform vector analysis in the demarcated area to see how contaminated it is or not, or population of vectors that is not very high. Carles will explain you later, but it's about the 5 or 0.5% or more or less, or 6%. Rives is a tool that was developed for EFSA, and the registration is free. But Rives is just a tool, but you need knowledge previous to use Rives, because finally it's to do the same as we were doing before, now with an electronic tool. But for that we need a good knowledge of the area to prospect, of course, a good knowledge of the method of sampling, and a good knowledge of the analysis method of the PCR. Well, this is what we use for, this is a screen of Rives, the program Rives, and also we use the PEST or webcast for Xylella and the guidelines, both from EFSA. And this is not provided in the legislation, but we consider that it's very important. We perform a surveillance around our demarcated area, 10 kilometers around, are divided in grids of 1 kilometer square. And we apply Rives to this area, okay, 80%, 1% as a free area. And we sample in these grids that Rives told us from 916 last year. We sampled in 232. So we have more than 1,400 samples in this area. Okay, then we have the rest of the territory, but here is more intensive. These are the points that we have taken samples in, the red ones in the demarcated area, and outside the demarcated area, the ones in there. And this map, or visual map of all the area, is completely sampled. Well, the other option that we have is containment. Not the other option. If eradication doesn't work, we can use containment. And we have the same points as in eradication, okay? In this general, just to explain you that containment nowadays, up to now, is only authorized in the parts of the territory that are listed in Annex 3, that are in Italy, the part of Lecce, Brindisi, and part of Taranto and Bari, in France, Corsica, and in Spain, the Balearic Islands. Only. In the rest of the Union, they have to apply an eradication plan, not a containment one. The main difference of the containment is in the removal of plants, because remember that in eradication I have to remove in the 50 meters around the positive everything, or mostly everything, but here just to remove the positive plant that we have detected. okay, immediately to the detection or before the vector flight. And there is a derogation for scientific purposes, plants with cultural or social value, so you can treat it and not remove it. Against vector, the same. We have to do phytosanitary treatments prior to the elimination of the plants. Of course, the treatments in plants with this cultural and social value, and we have the same agricultural practice to monitor the vector, okay, and to control the vector, sorry, with chemical, biological, or mechanical. The infected zone in a containment plan, well, the infected zone is the same, the 50 meters around, but here we don't remove the plants, we test them, okay? In these 50 meters around, we test the plants. This is the difference. Remove the positive plant and test all the rest, okay? And in the annual prospection, in the most appropriate times, we have a special area that is mainly for Apulia, for the Apulia zone, because the rest of the containment sites are islands, okay? So the last 5 kilometers from the border to from the border of the infected zone with the buffer zone, the last 5 kilometers of this infected zone must be prospected. Here with the 90% of certainty to detect on level of infected plants of 0.7, okay? But this is only for the 5 kilometers. Last 5 kilometers in the case of Apulia, or in the infected zones are the islands of Balearic or Corsica. Then we also have to sample and test the vectors, and in buffer zones, the regulation states that the confidence level is again the 90%, but we have to be we have to be able to detect the presence of 1% of infected plants. 0.7 for infected zone, and the buffer zone 91%. To destroy is the same as the eradication in situ or in a nearby place within the infected zone, and we can limit the destruction to branches and foliage, but revitalizing the root system, okay? And they have the same option, other measures in case of have complication with eradication. This is the same for both. What about planting specified plants in infected areas? So they can do it if they are grown on an insect-proof production, but in both cases, in containment or in eradication. If we are in containment, if we don't have this insect production, we can use in containment varieties considered as tolerant or resistant, and in eradication we don't have this option, okay? We have the option of insect proof, or we can plant the same plant species which have been tested and found free of Xylella based on prospecting activities, vale, carried out during at least the last 2 years. If the last 2 years in the prospecting activities we do not have any positive of this species, we can plant it. We have one case here in our region, and it's of course the Olea. We don't remove Olea, but we also permit Olea to be planted in the infected zones in the plots that we have destroyed previously, because up to now we don't have any positive in olive trees. Well, what happens with the movement of the plants? So inside the territory, the union territory, the regulation regulates this movement of specified plants inside and outside the demarcated areas, okay? In both cases, what is required? Of course, they have to be registered in a specific register that Carles will talk about, and of course, they have to circulate with plant passport, okay? It's necessary, the plant passport. This inside, if we were inside the demarcated area, we have two cases. One is to go out of this demarcated area, and the other one is just to circulate inside this their marketed area. Okay, to go out is very, very difficult. Movement out of specified plants and the movement from the infected areas to the buffer zones just can be done if they are grown in an authorized production site, protected against vectors, etc. Xylella has never been detected in this species in the demarcated area surveys in 3 previous years. This can be also the case for Olea europaea, but Commission have to approve it, and up to now we don't have this okay. The plants in vitro, they must be in sterile conditions, and the analysis for the batches must be 90% of confidence level, that is very high. And the resting BTs is you can immerse them in 45 minutes in hot water at 50 degrees, and this is enough to go outside. Okay, with the plant passport, of course. And the movement inside is the same as the site has to belong or belongs to a registered operator. Okay. The competent authority annual sampling. Okay, Paco. Vale. All the treatments against the vector must to be done, and all the the one that buys this plant have to know that this plant can go out of the demarcated area, so have to sign a declaration. This is the specific plant passport that we use inside the demarcated areas. Next to the traceability code, there must be these words: Xylella buffer zone or infected zone. And to go outside, the movement outside of the demarcated area is, as in the European Union with plant passport. We have specific requirements for some species that are considered the high risk, and the first movement, prior to the first movement, they must be tested under the say 80% and 1%. And the introduction for us is when it's coming from a third country, a country that is not part of the union territory. We have three different cases: a pest-free country, a pest-free area, or pest-free production sites. In all the articles in the regulation are the requirements, but mainly are the scheme of sampling, the phytosanitary certificate, and the annual inspections in the site of production, of course. This is for the Xylella-free country. We can also talk about a Xylella-free area of an infected country, so the same scheme, a phytosanitary certificate with the place of origin, and of course the inspections. And we also have the option of a production site, okay, free production site from our country. So we need here the phytosanitary certificate, but also an additional declaration and a list of the sites that are approved for the NPPO. Okay. And the official controls, we have controls inside, of course, and controls for the introduction, and all the batches must be sampled with, not all, but the batches must be sampled with the 80% and 1%, taking in account the ISPM number 31. And the last part that is very important also for Commission are the community communication, to explain the people what is happening, what if they can go, if it's a demarcated area, if it's outside the demarcated area. And well, I have some photos here, and sorry because it's very late, but that's all. Thank you very much, and if you have questions later.
Well, Amparo, thank you for your clear and very, very complete presentation. I think it must have been very interesting for the whole audience. Thanks.
Thank you.
And now it's time for the third speaker. The topic of his talk is certification of Xylella-free areas and products. And the name of the speaker is Carles Escrivá Gonzáles. Dr. Escrivá is graduated in Agricultural Technical Engineering in the Polytechnic University of Valencia, with professional career in the Ministry of Agriculture of the Autonomous Government of the Valencian Community in different positions. For example, it has been field and crop technician, ed technician for the Common Agricultural Policy of the European Union, pesticide residue surveillance technician, and seed and nursery plant technician, and currently he's the team leader of the plant health control group in nurseries and vegetable operator registry in the regional government at Comunitat Valenciana. And regarding Xylella fastidiosa, he coordinates the production control and certification on nursery plants in the regional government at Comunitat Valenciana. So I think the presentation could be very interesting. Carles, when you want, you can start the presentation.
Hola, gracias por la presentación, Paco. Vamos a ver, subimos un poco la presentación. Bueno, buenas tardes. Disculparme por no hablar en inglés. Voy a hacer la presentación en castellano. Creo que se entenderá bastante mejor que mi mal inglés. Y bueno, cualquier cosa que después quieran preguntar les podré contestar. Vale, nada, agradecer a la organización contar conmigo y mi compañera, Amparo Ferrer. Y bueno, pues coincidiremos, como trabajamos en el mismo servicio de sanidad vegetal, coincidiremos con algunas diapositivas, pero mejor, un poco, de alguna manera resaltaremos alguna cosa importante que queremos decir y por otra parte me servirá para ir un poco más rápido en la presentación. Bueno, voy a hacer un poco la presentación con tres bloques. Vamos a ver un poco la situación que ha explicado alguna cosa ya Amparo de la Xylella fastidiosa en la región de la Comunidad Valenciana, que somos una comunidad dentro de España, sabéis que nos regimos por comunidades autónomas y cada comunidad autónoma tiene su organismo de control, ¿vale? La vigilancia en las áreas libres de la enfermedad y otro bloque es lo que es la producción y el comercio de plantas de vivero. Bien, respecto a la situación de la Xylella en la Comunidad Valenciana, pues bueno, situaros un poco que somos una comunidad, estamos en la parte este, en el Levante, en lo que es el mar Mediterráneo. Somos una comunidad que, para situaros, tenemos somos principalmente cultivadores de cítricos, principalmente naranja y mandarina. Tenemos en cultivo unas 160.000 hectáreas, de almendras hay registradas 107.000 hectáreas, de frutales de hueso 9.700 hectáreas, de cultivo de olivo 94.000 hectáreas y cultivo de viña 63.000 hectáreas. Bien, nada, situaros, la primera detección tuvo lugar en Alicante, como os he comentado, nuestra comunidad autónoma. Somos 3 provincias, la provincia de Castellón, la provincia de Valencia, la provincia de Alicante, que es la parte sur, ¿vale? Y la primera detección fue en Alicante en el 2017 sobre cultivo de almendros. Bueno, haciendo un poco un repaso rápido de lo que fue desde entonces hasta ahora, pues bueno, pues en el primer momento la detección, como ya he comentado, fue en 2017 en un municipio que se denomina o se llama Castelló-Badalest, en la provincia de Alicante, en la provincia sur de la Comunidad Valenciana. Vale, un agricultor estuvo preguntando que tenía problemas en su cultivo y había una reducción y unos síntomas que eran desconocidos. Se hicieron varios analíticas. Al principio no salió nada hasta que dio un positivo, ¿vale? Eso luego se confirmó por PCR, incluso en plantas asintomáticas. Y fue el Laboratorio Nacional de Referencia el que confirmó la presencia de Xylella fastidiosa en ese campo, ¿vale? Y la subespecie, la cual fue clasificada, es la ST6. Desde entonces hasta ahora se han tomado en el área demarcada se han hecho más de 70.000 muestras y análisis. Y bueno, estos fueron los primeros síntomas que en el momento que apareció y estuvimos en la zona esta, vimos como síntomas en hojas de almendro. Vemos que hay almendros que les afectaba una parte, otros almendros totalmente. Hay que tener en cuenta que el cultivo del almendro en la provincia de Alicante es bajo secano, por lo tanto, además del estrés hídrico que sufren estos árboles como consecuencia de estar infectados de la Xylella, pues la afección puede ser más grave que sin ese estrés hídrico. Bueno, pues más fotografías de lo que empezó a partir del 2017, empezó a aparecer, que ya estuvimos haciendo prospección y tomando muestras, y como veis, pues es capaz de destruir los árboles, ¿no? Matar los árboles. Bien, un poco como vemos la situación en la Comunidad Valenciana, la parte norte Castellón, la parte central es Valencia y la parte sur es Alicante. Ese trocito pequeño es el área demarcada, ¿vale? Son 74 municipios que están parcialmente infectados, ¿vale? En zona infectada, perdón, y 74 municipios forman lo que son el área demarcada, ¿no? Que es un total de 138.000 hectáreas, lo que es el área demarcada, y dentro de esa área demarcada la zona infectada abarca 2.860 hectáreas. Bueno, un poco ya lo que hemos comentado, ¿vale? La superficie del área demarcada, de la zona infectada, los muestreos que hemos ido tomando en el área demarcada, más de 71.000 desde que empezó el primer brote, y fuera de la zona demarcada se han tomado más de 31.000, se han hecho más de 31.000 análisis, muestras son más, ¿vale? Se han erradicado muchos árboles, principalmente almendros, que estamos calculado con 170.000 árboles, de una superficie de unas 2.400 hectáreas. Se han realizado tratamientos periódicamente con piretroides. Por la parte de la administración se han realizado 3.100 hectáreas con piretroides y adicionalmente los agricultores en sus cultivos han realizado más de 27.000 hectáreas de tratamiento, ¿vale? Evidentemente hay una restricción para el movimiento del material, como ahora veremos, ¿vale? Y hay afectados 64 viveros en la zona de área demarcada, ¿vale? Los cuales la gran mayoría son comerciantes, son garden centers, ¿vale? Y además, pues bueno, pues se han estado haciendo durante todo este tiempo controles tanto en carreteras como aeropuertos, ¿vale? Y campañas de sensibilización. Bien, desde la primera detección hasta 2021 han habido 22 especies que han sido afectadas, ¿vale? Aquí vemos el porcentaje de positivos respecto al total y vemos que el almendro es el principal cultivo o la principal especie afectada, ¿no? Hay que tener en cuenta que también se han detectado en algunos albaricoqueros y algunos cirueleros algunos positivos, pero digamos que la zona no es propia del cultivo de estos frutales, ¿vale? Es propio más del cultivo de la almendra, que se adapta mucho mejor a el cultivo de secano, que hemos visto que es el predominante en la zona. El resto de especies, como veréis, son especies endémicas que forman parte del ecosistema natural, que también se toman muestras, y son, pues bueno, excepto excepto alguna especie, prácticamente todas las otras especies son especies silvestres, como he dicho, endémicas de la zona, ¿vale? Excepto la polígola mirtifolia, que realmente no es una planta que se reproduce a nivel de vivero para jardinería, pero el resto sí que suelen ser la práctica mayoría endémicas de la zona del área demarcada. En total, durante todo este tiempo, pues han sido cerca de 5.000 positivos. Aquí vemos lo que os comentaba, estas especies son propias de la zona de producción, el romero, el helicrisum, el calicatome, ¿vale? Y la polígala mirtifolia, pues que también es una de las especies muy sensibles a polígala y tienen de alguna manera un poco la restricción del movimiento. Bueno, en cuanto a vectores transmisores dentro de la zona infectada, se van tomando muestras para ver el nivel de infección y qué especies son capaces de realizar, tienen capacidad de infectar a las plantas, ¿vale? Como vemos desde que empezamos el muestreo hasta 2019, el Philaenus spumarius era el que prácticamente se detectaban los positivos, ¿no? Y además se detectó algún positivo también, 20 muestras desde 2000, de Neophylaenus campestris. Bien, en 2020 continuó un poco la misma tendencia, es decir, solo se encontraron vectores transmisores en estos insectos, pero ya en el 2021 ya el Neophylaenus lineatus se tomaron mucho menos muestras, pero salieron más positivos, por eso aumenta el porcentaje. Pero bueno, en definitiva, es una especie más que se ha detectado este año anterior, ¿vale? En la cual también es capaz de transmitir la enfermedad en el área demarcada. Bien, el control el control y vigilancia de las áreas libres de la enfermedad. Vamos a ver un poco lo que estamos haciendo. Como veis, el mapa que en su momento hizo Purcell sobre los riesgos potenciales de la enfermedad en base a las temperaturas, a la media de temperaturas, ¿vale? Es muy coincidente con este otro mapa, ¿vale? Que tenemos a la derecha, que son los puntos de la red de vigilancia, la red de vigilancia fitosanitaria que tenemos para el control de cítricos. Bueno, hay que decir que además de la red de vigilancia de cítricos, que está compuesta de 136 puntos, forma parte también de este control 938 puntos para el control de la ceratitis capitata y también hay 60 puntos para el control del Bractocea oleae y además en estos 136 puntos se incrementaron las trampas pegajosas amarillas para el control también de la Xylella. Aprovechando que ya teníamos los puntos de control y estos se tienen que visitar periódicamente, pues se aprovechó toda esta red para añadir trampas específicas amarillas pegajosas para el control de insectos vectores y si existe la posibilidad de analizarlos, poder analizarlos para ver si alguno tiene la infección. Hasta ahora ningún insecto vector fuera de la zona demarcada se ha encontrado positivo a la enfermedad, ¿vale? Desde el principio hasta ahora desde 2015 que tenemos este programa de red y vigilancia, hasta ahora se han llegado a controlar más de 120.000 trampas. Bien, como os he comentado, los puntos de vigilancia de cítricos, ¿vale? Que habíamos comentado que eran 136, estos puntos de vigilancia, tenemos diferentes 8 tipos concretamente de trampas para el control de todos los insectos, ¿vale? Insectos cuarentenarios que pudieran entrar a nuestra comunidad autónoma y llevar así un control para en el momento que pudiera aparecer un insecto que está cualificado por la normativa europea cuarentenario, poder detectar el brote y poder de alguna manera actuar lo más rápidamente posible. Bueno, para que veáis un poco también nuestra situación, ¿vale? En la Comunidad Valenciana es un cultivo muy intensivo, en los cuales las parcelas son muy pequeñas, hay muchas parcelas y eso evidentemente dificulta el control. Hay una media de dimensión por explotación de 3,6 hectáreas en campos de secano y 1,1 hectárea en irrigación. Eso nos complica mucho el control. Bien, bueno, pues para realizar los controles, de alguna manera tenemos en cuenta los métodos analíticos para la determinación de la enfermedad, que de alguna manera vienen indicados en el Pest Survey Card del EFSA, y además la metodología también del muestreo, y así como las directrices de muestreo basado por el riesgo también del EFSA. Además, tenemos un plan de contingencia a nivel nacional y un plan de contingencia a nivel regional, que está un poco más adaptado a nuestras condiciones. No lo he nombrado, pero anteriormente hemos visto en el mapa de España que teníamos, y también lo ha comentado mi compañera, por una parte tenemos las Islas Baleares, donde está presente la enfermedad en todas las subespecies, y claro, no es, por una parte el programa de contingencia nacional está basado con unas indicaciones generales, pero ya cada comunidad autónoma, en función de cómo le afecta la enfermedad, tiene su propio plan de contingencia, y digamos que todo este conjunto es lo que hace que de alguna manera llevamos el control en las áreas libres de Xylella. Bien, el control supone los controles en los viveros productores y garden center. Estos controles suponen, por una parte, el control documental, y dentro del documental es muy importante, luego lo veremos, lo remarcaremos, lo que es el concepto ya, bueno, o lo que se introdujo, la última normativa, que es la trazabilidad. Se realizan inspecciones visuales y se toman muestras y se realizan análisis. Por otra parte, también hay controles en lo que son campos de cultivo y en el medio ambiente, así como también tenemos controles en los parques públicos. Bien, como he comentado, pues son las trampas pegajosas las que controlamos en las áreas en las áreas libres de la enfermedad, para el control de los insectos vectores y realizar análisis para comprobar de que estén libres de la enfermedad cuando sea posible. Bien, para que hagáis un poco una idea, el año pasado tuvimos un muestreo de 5.700 muestras en lo que son viveros y unas 1.500 muestras también en otros lugares, en el medio ambiente, en los campos y parques y jardines. ¿Vale? En total fueron 2.107 inspecciones y en otros lugares, en el medio ambiente, encontramos un positivo, lo que fue necesario ampliar lo que es la zona demarcada. Bien, como veis, el muestreo que en el año 2021 lo que abarca, es decir, está abarcando muchas especies diferentes y en función un poco de, o un poco no, un mucho, en función de la importancia del cultivo, pues se toman más o menos muestras, ¿vale? Como veis, solo dio un positivo a Helichrysum stoecas en el borde de la zona demarcada, como ahora veremos, ¿vale? Pero el resto de muestras salieron negativas. Bien. Como hemos comentado, hay diferentes controles, lo que son en las áreas agrícolas, en el medio ambiente o en las áreas urbanas, se está utilizando actualmente el RIBES, ¿vale? El RIBES, que es una metodología puesta a punto por el EFSA y cumpliendo lo que nos indica o nos marca el reglamento de Xylella, el último reglamento, el 2020-1201 de la Unión Europea, en el que el nivel de la certeza mínima tiene que ser del 80%, ¿vale? Y el nivel de presencia en vegetales infectados ha de ser del 1%. Bien, como vemos aquí, además de la zona demarcada que está en morado, tenemos un borde envolvente a esta zona demarcada en el cual intensificamos el muestreo y utilizamos el método RIBES, ¿vale? Para, de alguna manera, sea estadísticamente fiable el control que realizamos. Entonces, esta área está dividida en 916 cuadrículas de kilómetro por kilómetro y se han tomado muestras en 232 cuadrículas de esta área envolvente. Se están realizando unas 1.300, 1.400 análisis cada año en toda esta zona y un poco siguiendo las indicaciones de la normativa y utilizando la herramienta, ¿vale?, estadística RIBES para tener una certeza mínima del 80% con un nivel de presencia de vegetales inspeccionados del 1%. Bien, en 2020 nos vamos al 2020, los controles que se hicieron en toda esa área envolvente, hubieron 2 positivos de almendros, aquí los tenemos, que se salen un poco, por lo tanto se modificó lo que es la zona demarcada. Se tomaron entonces unas 1.335 análisis en 2020 y en 2021, como hemos visto antes, se detectó un Helichrysum stoecas también en la zona envolvente, ¿vale? Y en el 2021, pues bueno, en esta zona, de esta zona se hicieron 1.536 análisis. Es decir, va avanzando, pero muy poco a poco y todavía sigue retenida en lo que es la zona envolvente. Pensamos que es importante que intentarlo retener y intensificar todo el muestreo en esta área para que no sea, para intentar retener la enfermedad en esta zona. Bueno, y ahora un poco hablaros del último bloque, que es la producción y el comercio de plantas de vivero, ¿vale? Por una parte, la diseminación de la enfermedad es por insectos vectores a corta distancia, pero por otra parte es el material vegetal cuando infectado, cuando circula, cuando transmite la enfermedad a largas distancias, y es como creemos que nos ha venido de otros países a España. Bueno, desde que estamos en la Unión Europea, en 1993 hay libertad de movimiento entre los Estados miembros y se tienen que de alguna manera controlar, como ahora veremos, los puntos de producción, de origen de esas plantas antes de poner en circulación para minimizar los riesgos que puedan haber en la transmisión de enfermedades. Además, se pueden hacer los controles en cualquier momento de la cadena comercial, pero principalmente en el origen. Bien, esto ya lo ha comentado también mi compañera. En 2019 fue efectiva el reglamento de 2016, que, bueno, de sanidad vegetal, que de alguna manera regula lo que es el pasaporte fitosanitario. Luego hay otro reglamento importante a este nivel de movimiento de planta, que es el formato del pasaporte, que también hemos visto alguna cosa, y las condiciones uniformes para la ejecución, es decir, de que tienen que estar libres, que esto lo pone el reglamento 2019-2062, que vienen indicadas las enfermedades de cuarentena y las plagas reguladas no cuarentenarias, y de la que tienen que estar libres todas las plantas para el movimiento a través de la Unión Europea. Bueno, de alguna manera, y resumiendo, hay una obligatoriedad de que los operadores profesionales estén en un registro que en este caso es único a nivel ministerio, pero cada comunidad autónoma es el competente en los operadores que tengan la sede social allí. Por lo tanto, cada operador se registra en su comunidad autónoma y desde la administración, digamos que aportamos al registro nacional los operadores que están registrados. Bueno, también hay una serie de obligaciones de esos operadores. El pasaporte fitosanitario, que también ha cambiado con la nueva normativa y que ahora veremos muy rápidamente, y entra en concepto también lo que es la trazabilidad, que hasta ahora no estaba contemplada en la normativa europea. Bien, de alguna manera, ¿quién tiene que registrarse? Pues hay un registro que tienen que estar todos los operadores, comerciantes, que de alguna manera produzcan o distribuyan planta a nivel comercial, ¿vale? ¿Quién debe registrarse? Pues, como he comentado, los que muevan planta o comercialicen planta, ¿vale? Tienen que estar autorizados para la emisión del pasaporte fitosanitario por las autoridades competentes, ¿vale? Y para eso, de alguna manera, tienen que solicitar ellos la expedición del pasaporte fitosanitario. Estas son las condiciones para que un operador profesional registrado pueda emitir un pasaporte fitosanitario, un plan passport. Luego hay unas excepciones, que son aquellos operadores que venden directamente, ¿vale?, a la producción final, ¿vale? Los que tienen, los que venden o suministran cantidades vegetales, ¿vale?, finalmente al usuario final, excepto aquellos que tengan comercio a larga distancia, es decir, los que comercializan plantas por Internet, aunque debo decir que se nos escapan muchas veces estas empresas y la verdad es que es un comercio hoy en día importante que también debemos estar muy pendientes. Bueno, el procedimiento que nosotros tenemos para un operador profesional es que se debe de registrar. Online tenemos una web donde se debe de registrar y se debe registrar en los vegetales o grupo de vegetales o especies que vienen indicadas en el impreso, que de alguna manera son todas estas, ¿no? Son los frutales de hueso y pepita, el olivo, y cada uno de ellos se debe inscribir en ese grupo o especie o grupo de especies vegetales, ¿vale? Actualmente tenemos 1.200 productores y comerciantes, hay aproximadamente inscritos 450. Cuando se realizan las inspecciones y se comprueba que el operador cumple con los requisitos, se le realiza y se emite un certificado de inscripción. Bien. ¿Cuáles son las obligaciones del operador profesional? Pues bueno, tienen que realizar una declaración anual, tienen que llevar una trazabilidad, ¿vale? Tienen que ellos realizar sus exámenes, identificar los puntos críticos, guardar esos documentos de pasaporte durante 3 años, ¿vale? Y permitir y vamos a ver, voy a pasar rápido, vale. Y de qué manera realizan lo que son las declaraciones anuales. Tenemos un sistema online de gestión de esta información en el cual se identifica al productor, de alguna manera él está identificado con los grupos de vegetales que está autorizado a producir, rellena online la producción anual, en el cual tiene que identificar los polígonos y las parcelas donde está el cultivo. Luego el sistema genera un número de lote que puede servir para la trazabilidad, aunque ellos pueden también generar un lote propio, de manera que toda esa información anualmente se queda en el sistema y como he comentado, se debe de localizar mediante la parcela y la producción, perdón, la parcela mediante el sistema que tenemos de indicación geográfica que se denomina aquí SIGPAC, ¿vale? Que es conocido y se puede consultar online cualquier persona, ¿vale? Y nada, ya comentar que, bueno, pues que una vez autorizado, pues ese material para la circulación tiene que ir con su pasaporte fitosanitario, que debe de acompañar a la unidad comercial en todo su movimiento a través de la Unión Europea, ¿vale? Y ese certificado, de alguna manera, lo que nos está diciendo que ha sido controlado y está libre de plagas de cuarentena y plagas reguladas no cuarentenarias, ¿vale? Y respecto a la anterior normativa, es que es necesario que todos los vegetales destinados a plantación lleven ese pasaporte fitosanitario en la circulación de este material. Aquí tenemos una serie de modelos de pasaporte fitosanitario que vienen regulados en el reglamento 2017-2313, que dependiendo de la especie y de la categoría de la planta producida, pues puede tener diferentes colores, pero tiene que mantener toda esta información. Y como vemos, el código de trazabilidad también ha de alguna manera, de figurar en el pasaporte fitosanitario. Bueno, aquí vemos algunos ejemplos de comercialización. Pueden estar en la maceta, pueden estar aquí en la misma planta, pueden estar en forma de etiqueta pegada a la misma planta, ¿vale? Aquí tenemos otros ejemplos. Estos son naranjos producidos en campo, en la viña planta de viña que viene en el envase de comercialización. Y pues bueno, pues...
Carles, estamos ya
sí,
en tiempo.
Vale. Yo creo que con esto voy a terminar. Deciros que se tomaron 5.700 muestras el año pasado en lo que son en los viveros y comercios. Y bueno, esto no voy a entrar porque ya lo ha explicado mi compañera Amparo Ferrer y no quiero volver un poco a retomar las condiciones que nos indica el reglamento para el control de las plantas destinadas al comercio, así como otros campos de cultivo y otros cultivos. Bueno, deciros que en plantas de vivero utilizamos para el control la norma NINF 31, que nos indica el nivel de confianza y el de presencia, que para un lote de 4.000 plantas se deben de inspeccionar 157 como ejemplo. Es muy fácil de hacer, es diferente al RIBES, pero a nivel práctico es muy práctico. Y bien, bueno, por aquí tenemos algunos inspectores haciendo inspecciones y tomando muestras. Y bueno, y esto es un poco más lo que hemos comentado del movimiento, cuándo se puede mover o no se puede mover las plantas y en qué condiciones. Pero bueno, no voy a remarcarlo más porque ya Amparo, mi compañera, lo ha explicado. Nada, comentar que nosotros somos una comunidad importante en producción de árboles, en este caso árboles ornamentales de olea. Estamos en la producción aproximadamente de 1.800.000 unidades, que también se han producido de árboles recuperados. También tenemos una producción bastante importante, sobre todo de olea, que sabéis que es una especie que siempre estamos muy pendientes de no poder encontrar ningún positivo. Y pues bueno, también en cuanto a arbustos, también Nerium oleander, la principal planta que producimos, anualmente unas 10 millones de unidades, y digamos que todas estas plantas van destinadas a la exportación a la Unión Europea, con lo que siempre estamos en el punto de mira y tenemos que tener la seguridad de que las plantas salgan en las mejores condiciones. Lo mismo nos sucede en aromáticas. Como veis, todas las especies más sensibles son las que más cultivamos y más comercializamos a nivel europeo. Y nada, y comentar ya para finalizar que la trazabilidad como un elemento introducido es muy importante y se debe de llevar siempre, ¿vale? Porque nos puede llevar siempre al origen de un brote en caso de que algún laboratorio detecte el brote, ¿de acuerdo? Y bueno, y nada más, gracias por vuestra atención y disculparme por haber excedido un poco el tiempo. Gracias. Gracias, Paco.
Thanks to you, Carles, for the presentation. You have perfectly completed this intense and interesting fifth session with your presentation. And now,
thank you.
And now I would like to invite to all the speakers to participate in the debate and to answering the potential questions of the participants in the workshop. Okay, so to start this part of the session, we have one question to Carlos from Elvecio Coleta Filo. The question is, in your opinion, what is the most favorable environment condition that can potentialize or reduce Xylella fastidiosa related disease?
Thank you, Francisco and Elvecio, for the question. I think in this region, this is a tropical region, one thing that is favorable for not seeing a lot of symptoms is that the temperature is very stable throughout the year. We don't have very drastic changes or seasons. And this may be one factor that is in favor of not seeing drastic symptoms in plants, although we know they are colonized. Also, we have changes from dry to rainy season in humidity, but they're not also drastic. So there's a lot of humidity in our conditions, and these are some environmental factors that may be attributed to this. But another thing, I think, another factor is to monitor biodiversity, because although we have these monocultural activities, we see still a lot of diversity in vectors and in genetic strains. And this is a thing to be doing surveillance and being careful, because there are cases like in the United States when there was a displacement of a vector for natural vectors, there was a spillover in Xylella fastidiosa and Pierce disease. So if we can monitor diversity as like a healthy ecosystem within the agricultural conditions, if we see that there is a vector that is displacing other frequent vectors in these conditions, or we're seeing that there is just one genetic strain that is fixating in one crop, this could be the starting point of a spillover and a possible outbreak. So I think monitoring diversity could be a good idea to have an idea of how healthy or maybe these conditions avoid to have the fixation of vectors and strains that may turn out to be an outbreak in some point. That is
okay.
I don't know
Thank you, Carlos. A question to Amparo now, from Laura Garita. Amparo, during the collection material for evaluation, was included ornamental species or maybe plants considered weeds?
Sorry, Paco, but I don't understand the collection, material collection. I don't understand the question.
I think it could be. I'm not sure, but it could be when you are searching for the presence of the bacterium in the plants. You take only weeds or also ornamental species.
No,
Possibly,
we take a lot of samples of a lot of different species, not only ornamental, also as considered like weeds, of course, because it could be a reservoir of the bacteria there. So we try to sample the host plants, the complete list of the Annex 1 of the regulation.
Mhm.
Carles, one question to you. In English, it's okay. or I can tell the question in English and after that in Spanish. It's from Laura Garita. The symptoms that are now associated with Xylella fastidiosa were formerly associated with another disease or physiological situation of the plant. Quiere decir si los síntomas que asociamos ahora a Xylella fastidiosa en la Comunidad Valenciana antes habían sido asociados a otra enfermedad o a otra situación fisiológica de la planta.
Sí, efectivamente es así. Efectivamente, al principio, cuando el primer agricultor nos llamó en 2017, sí que pensamos que era debido a las condiciones de estrés de agua que sufren este tipo de cultivos en zonas de un secano, por decirlo, rabioso, en el cual en estos años no acompañaban las lluvias y de alguna manera pensábamos que sí que podía venir influenciado por esas condiciones meteorológicas y de suelo, evidentemente. Y de hecho, en los primeros controles nos dieron negativos, aunque estaba claro que había una serie de síntomas diferentes y se insistió y efectivamente es cuando vimos que dio positivo, ¿no? Pero ahora actualmente ya por eso mismo, de alguna manera, cuando se toman muestras y se vea algo sospechoso, no, aunque hemos visto unas fotografías de una determinada sintomatología, ya lo que se hace es tomar la muestra y estar seguros de que no se trata de Xylella.
Okay, so more or less, Carles has said that yes, it's true. Symptomatology were associated at the beginning with other situation mainly with a water stress in the almond trees, because was at this time the situation, the climatological situation in the Valencian community was very dry, so this was a possibility. And in fact, the first analysis of this the leaves of these trees were negative. So the surprise were when in a second or in a third analysis they were positives, and at that moment they knew that these plants were the presence of Xylella. And now, once the presence of Xylella is well known in the Valencian community, this possible confusion between the presence or not due to the symptoms is not easy to occur, because now it's very clear to do the analysis, the perfect analysis, to know the presence of the bacterium in the plants. But it's true, the question of Laura Garita is true at the first moment. It was true at the first moment. Okay, Carlos, we have another question from Laura Garita also to you. Have you carried out analysis of the genetic diversity of Xylella inside the insect vector? Do you have any information about it?
Okay. We have indirect evidence, because in the transmission assays done in plants, when we screen with microsatellites of the positive plants that were positive due to vector transmission, we see different patterns of microsatellites. This means that the possibility that there are more than one circulating strain. But we have to go back to the insects and do this individually and try to see what kind of diversity using microsatellites we can obtain to understand if one vector can carry more than one of the circulating strains, or, for example, if there are like competition possibilities within a vector, or it's more if one vector is already infected, if it can acquire another strain of Xylella. All of these type of assays, we have to look back, and we have all the material to do it. So I think it's something we can further study and have those sensors.
Thank you. Well, now a question to Amparo from Joao Lopez. The removal of specified host plants of Xylella over a wide area, such as in a buffer zone, is important in regions where there are good chances to eradicate or to confine the pathogen. So the question is, what are the prospects for eradication of Xylella fastidiosa in regions of continental Spain that are currently affected by the bacterium?
Well, good question, Joao. It's very difficult, of course. We have the example in Apulia, in the region of Italy, because they started, and now they are the only part of Europe that is continental and is under containment. For the Commission, there are no containment in the continental part of Europe, so we have to apply the eradication. But as you said, it's very, very difficult. But we try to work in the borders of the demarcated area, always trying not to expand the disease to other parts or other territories in the Union. So the big effort must be in these borders, in this area, and coming from the border into the insider part of the demarcated area, trying not to disseminate the disease from the border to outside. But it's very difficult, so it's a hard work, we know, because we are 5 years dealing with that and with a lot of problems. But, well, as EFSA states, the better containment is the eradication. So we have to continue in that way, and we are trying to do it the best as we know. Paco, el micro.
A question that I think is to Amparo, to Carles, one of the two. From Sofia Carvajal. The bacterium found in almond trees has a different site of introduction than the one found in Italy. I think that it refers to the geographical area of introduction, of course. Carles or Amparo?
Our outbreak is nothing to see with the one in Italy. So it's another different introduction. It's another species, another ST, another host. And well, we still don't know the origin of our outbreak. We don't know if we think that perhaps it's more years than we think, and perhaps in the introduction with material, with prunus material coming from the United States. This, I think, it's in an article of Blanca Landa Doctor. So there's a relation between our strain and one in California. So perhaps our introduction in our outbreak was different from, different. If in Italy, the suspect, as Carlos explained before, was in ornamental trees coming from Costa Rica because of the strain of the bacteria. But in our case, we think it comes also with some material. Yes. I don't know if Carles can add something to what I say, or it's enough. Okay. I don't know if Paco is present.
We lost Paco.
We lost Paco, yes.
Bueno.
Okay, it's Joao here again. Joao, the micro, we can't hear you.
Bueno, yo aprovecho porque hay otra pregunta sobre pasaporte fitosanitario y efectivamente el pasaporte fitosanitario es necesario para la exportación de el material vegetal que se exporta a la Unión Europea. Es obligatorio que todas las unidades comerciales, como habéis visto, lleven su pasaporte y con ello se ponen en el origen y puede llegar hasta el destino, o debe de llegar hasta el destino si no pasa por un comerciante con ese pasaporte. Porque un poco la idea es con ese pasaporte ser capaces, mediante la trazabilidad, en caso de detectar algún brote, llegar al origen de ese brote. Entonces, es obligado. Lo que son exportaciones a terceros países ya es otra cosa, ya se requiere de un certificado fitosanitario donde cada país ya pone las condiciones necesarias para su introducción. Pero lo que es a través de la Unión Europea, todos los materiales vegetales que se tengan movimiento a través de la Unión deben llevar su pasaporte fitosanitario.
Okay. Sorry for my absence, but it had been a problem with the computer. So I think there are not more questions, I think. So in that case, I want to thanks to all the speakers for this interesting session. I think it has been very interesting at all the other 4 previous sessions. And I think this is the moment, Joao, to close the workshop. And I think it's your time.
Okay, thank you, Francisco. Thank you all the speakers, Escrivá, Gonzáles, Amparo, Ferrer, Carlos, Chacon. I would like to congratulate you all for this very nice session. And I think with this we are concluding our 5 virtual sessions of the Xylella fastidiosa workshop. And we are as organizers, we are very happy with the results. We think the workshop fully reached its goal of providing a good overview of several aspects of Xylella fastidiosa, from basics like taxonomy, the classification, interactions with plants and vectors, to applied aspects such as management and regulation, as we talked today. So I think this is very important to raise debate about this important pathogen and also for management. So on behalf of the organizing institutions, ESALC, University of São Paulo, and the Citriculture Center of the Instituto Agronômico de Campinas, Brazil, I would like to first special thanks to this session 5 participants, moderator and speakers, our special thanks. Also, I would like to thank all members of the organizing committee, and a special thanks to some support personnel who helped us through all these sessions, the virtual sessions, and also the practical sessions. Joyce Froza, Simone Prado, Mariana Boss Esteves, Regina Moraes, Fabiano Pereira, Euclides Villanova, and student Maria Eduarda. Without them, it would be impossible to do all these virtual sessions. Thank you, the supporting institutions, especially CITED, through the Chifas, Rede Ibero-Americana para a Vigilância de Xylella fastidiosa, for the support and stimulus since the beginning. They provide us the motivation to start this initiative, and also for other organs that help us to support speakers and travel, such as Department of Entomology and Acarology of the University of São Paulo. With this, we thank all the participants, and we conclude the Xylella fastidiosa workshop from management, from diagnosis to management. Thank you very much.
Thank you.
Thank you.
Tirar todo mundo antes para aparecer.